All right, guys, second part of the midterm for Math 1700. This, again, you guys do whatever at this stage of the game is best for you. And it's always hard for me to say as your professor because it varies from student to student. But again, I think for most students, actually this should be part two. So, but I think most students benefit the greatest by trying these problems. Math is not a spectator sport, people. You probably figured that out, but it takes more work. The easiest thing to do is just prop your feet up, sit back and watch me do everything. But I think the greatest benefit is you trying these things first, and then if you're successful, then it's always a good thing to watch me do it, and you get the same answer, and life is good. If you're running into problems, that shows you at this point that you don't know how to do these problems yet, and you need more practice. So it's kind of good at this stage of the game to simulate what you're going to run into on your midterm. All right, gang, let's go for it. Evaluate log base 3 of 100 equal y. Well, this is telling me that, again, I think I've mentioned this in previous videos. My mind just doesn't think in logarithms. My mind thinks in exponential functions. So I want to convert this to an exponential function. I know from the past that I take the natural log of both sides. I know from the past that I bring this y out front. And I know from the past that I divide both sides by the natural log of whatever is with the variable I'm trying to solve for. Now, I've seen students before try to take shortcuts and think, well, I've got a natural log here and I got a natural log here. It looks like those natural logs would just combine and make this. It doesn't. I'll illustrate that here in just a second that it doesn't do that. So, gang, I've got natural log of 100 divided by the natural log of 3. So the answer in this situation would be 4.19. Now, I can always check that because I need 3 raised to that power to be 100, and we'll see that it is. So my answer here would be y equals 4.19. Okay? Now, you'll see that if I do it the other way, if I just take the natural log of 100 divided by 3, that I don't get the same thing. In fact, that, when I raise 3 to that power, I don't get the right answer because I did the problem wrong, right? Just made a mistake. Okay, solve the following. Guys, I don't need to do anything here. When I have base 10, I think log key. So all I got to do to solve this problem is put log of 81 in my calculator. And my answer is 1.91. Don't believe me? 10 raised to that value gives us 81. Second problem, e to the x. Guys, don't need to think about it. Base e, use your natural log key. Natural log of 100 is going to give us the answer to this problem. Again, don't believe me? Take e to the x, raised to the answer that we just solved for, and you can see we get 100. So guys, our answer would be x equal 4.61. So guys, base e, natural log key takes care of it. Base 10, your log key. But the other types of problems we run into is when we have a base other than 10 or e. So guys, what we do here, change the base theorem. So we're going to take the natural log of both sides. Just like before, bring your x up front. Because I expect y'all to be able to do this when you get on your midterm. Divide both sides by the natural log of 5. So x is going to be the natural log of 150 over the natural log of 5. Don't do anything goofy like this up here, unless you just want to miss the problem. So we'll take the natural log of 150 divided by the natural log of 5. So we get 3.11 as our answer, and we can see that 5 raised to that answer does indeed give us 150. All right. Problem 3. Mike invested his annual bonus check a few years ago, earning interest that was compounded annually. So guys, compounded annually, what do we think? N is equal to 1. 5 years after investing his bonus check, he had $44,242. 10 years after investing his bonus check, he had $59,766. How much did he invest, and what was his interest rate? Well, gang, what we know here is we've got two ordered pairs. We've got 5 years later. We got 44,242. And 10 years later, he's got 59,766. Now what we got to do is we've got to fit an exponential function that passes through 5 44,242 and 10 59,766. Now, in the context of this model is going to follow our A equal P times 1 plus R raised to the T power, because again, N is equal to 1. So we're going to have two variables here. We're going to have our principal and our rate that we're going to solve for. Now, you kind of think about this as y equals A times B to the x power, where A is our leading coefficient, B is the 1 plus the R, and x is our time. Well, guys, we got a calculator function that takes care of that for us, but the first thing we got to do is, just like in a linear function, we got to put in our values. All right? Is that right? Yeah. So we'll go to Stat, we'll go over to Calc, and we're going to come all the way down here and try to find where it says Exponential Regression. I want to put in L1, comma L2. And I'm going to get my answer in form of this A times B raised to the x power. So my A in this situation is 32,750.30. Times 1.062 raised to the T power. Now, first thing I ask is, how much did he invest? Well, guys, when I put T equals 0 up here, which would be the amount when we had our investment, then anything raised to the 0 power is just 1 times this number tells me my investment. So the amount invested was $32,700, well, $750.30. The rate is going to be found here, and it's going to be the amount that's added to the 1, because 1 plus our rate, so this is going to be 1 plus 0.062, so our rate is 6.2%. That's a little bit more challenging. Number 14, Kate borrows $10,000. Sum is from her friend, twice as much as that at the bank. Remainder, parents, she pays a total of $830. How much she borrow from each source? Well, guys, this is a system of linear equations. So each source, we're going to have a variable for each source. Looks like amount from the friend. We'll let Y be the amount from the bank. And we'll let Z be the amount from parents. All right. So 3 variables. So guys, we got to come up with 3 equations. So first thing we see is from all these sources, she has $10,000 that she's borrowed. Next thing we see is we have the 8% plus the 9% plus the 10%, no, I'm sorry, plus the 5% from her parents, and she pays everybody a total of $830 interest. Now, next thing we got to do is we got to come in, we got to have another equation. Where else do we have information in here? And we see that twice as much as that. So twice as much from the bank. So we know that we've got some relationship between X and Y. So twice as much is invested in the bank. Now this goes back again, let's think it through. Let's say she's got $2,000 that she invested with the bank, or borrowed from the bank, and $1,000 from her friend. So twice as much is over here, but guys, when I make those two things equal, I have to multiply the smaller by 2. All right, gang, going to set up my augmented matrix. Okay, my X, I got to bring the Y over to make a -1. I have no Z in this problem, and I have no constant in that equation. So, gang, I got a 3 by 4, so I'm going to have 1, 1, 1, 10,000, and 0.08, 0.09, and 0.05, so my interest is going to be 830, and then I have 2 minus 1, 0, 0. So guys, just like before, just like before, I'm going to go to matrix and insert the matrix A. And it looks like she borrowed $3,000 from her friend. $6,000 from the bank, and $1,000 from her parents. Now, it says that twice as much needs to be from the bank that was from the friend. So we see that we took care of that. And sure enough, we have $10,000, and you can check the interest if you so want to do that. All right, gang, last problem. Cool. So sad. So much fun. All right. Write the information in the first and second tables as a 2x4 matrix A and a 4x2 matrix B. So I need a 2x4, so it looks like to get a 2x4, I'm going to have to put the years here in Canada, Argentina, and Japan. And what we're given here, we're given the population in millions for various years. So I'm going to have 278.1 and 31.6, 37.8, and 126.8. So I have 300.1, 34.3, 41.1, and 127.3. Now, guys, I would slow down here a little bit, and I would just make sure, again, we need a 2x4, which says we need 2 rows and 4 columns. This is where I get my information in terms of 2s, so I need the 2001 to correspond, and everything looks good. Now, the next thing I need is I need a matrix with 4 rows and 2 columns. And I can see that my 4 rows have to come from the US, Canada, Argentina, and Japan. And I have my birth rate and my death rate. So my birth, actually this is just going to go directly like this, and I'm not going to write all this out. And my death for Japan would be 0.00925. All right, and I'm pretty sure we're going to have to enter this in the calculator eventually anyway, so we'll get to, find the product A and B. All right, I knew it was coming. All right, so let's go in and do that. So let's enter in our calculator these matrices. And I'm going to enter just as A and B. So, guys, I need a 2x4. So I have 278.1, 31.6, 37.8, and 126.8, and 300.1, 34.3, and 41.1. And 127.3. All right, next thing I need to do is get out of that, go back into it, go to Edit, go down to Matrix B. Again, I need a 4x2. Now, this will take a little bit more work because you got 0.01425, 0.01145, 0.0175, and 0.00945. Wow, that's what I get for not watching. So it's going side to side, so I just messed all that up. All right, let's just do it this way. Okay. 0.00865, 0.00775, 0.0077 or 755. Well, gang, I'm struggling here. What's going on here? This is ridiculous. All right, let's make sure we got this right, because I'm just bombing this problem. Okay, that's right. That's right. And 0.00925. All right, let's make sure we get this right, because I've certainly tried every way in the world to blotch up this problem. All right, looks good. All right. So our question over here says, find the product and interpret the entries. Now, gang, I'll go ahead and tell you, I'm not going to write all this out, but we are multiplying A times B, and A times B is a 2 by 4, and B is a 4 by 2. So those two numbers are the same, so we can multiply, so we're going to end up with a 2 by 2 matrix. And guys, actually, I'm going to write this out. So we're going to end up with a 2 by 2 matrix. So let's get out of this. Go into matrix, matrix A, times matrix B, and we get 2 by 2. So we have 6.18, 4.10, 6.59, and 4.34. Now, to determine what these entries mean, keep in mind that the rows of this matrix will come from the rows of the first matrix. So I know here I've got 2001, 2010, and the columns not only come numerically from the second matrix, but they literally represent what's being represented in the columns of the second matrix. So guys, what we end up here, we get the births, and let's see, these are populations in millions. So this says that the birth was in the United States in 2001 was 6.1 million. 2010, 6.59 million. 4.10 million. 4.34 million. So according to the product matrix, what's the number of people born in these four countries in combined 2010? Well, it's going to be 4.34 plus 6.59. So that's going to be, what, 13, 9, 10.93 billion. Wait a minute, that's not right. What's the total number of people born? No, forget that, because I included death. So the total number of people born will be 6.59 billion people, just in these four countries. That is insane, isn't it? No, I'm sorry, it's millions. I was getting ready to say, that's just unbelievable. But still, almost 7 million people born, and it looks like in 2010 there were 4.34 million who died. So you've got almost about 2.2 million more people who were born in 2010 that died in these four countries. So if we talk about a population explosion, you can kind of follow this model out and imagine going out to maybe 2050 if it remains this way. Actually, that's kind of staggering. But anyway, let's keep on finite math here. We'll worry about population explosion in a later date. Not that we can do anything about it. So guys, I'm done. I hope this has helped. I'll probably put up your My Math Lab assignment will be a review, so it'll give you more chance to. Some people say, "Well, it was a review. I didn't know I had to submit it." Yeah, you got to submit it. It's a homework assignment, but it's kind of geared toward getting you to learn more about what you're going to have to do in your midterm. So, guys, I'm done. Have a good one.